Sean Henson for Video Diary, Sprint 9, the final sprint. So today, in this part of the video, I'll showcase the ice block math class, then switch on to the visualizer, and then last I'll showcase the collision system. So first we have the ice block math class, which is a singleton. So this can be called anywhere with some of the basic math functions that I had to keep retyping. So we just put them all here to make it less likely to have a mistype. So we have the usual find max, find min for OBBs and ABBs. We have the clamp, so using that for sphere collisions with OBBs. We have what I call group check, which is used to help set up the interval check for the group boxes or group collisions box. Standard access theorem interval check used for the OBBs. And these two values right here I just have for when I was setting the min and max of an object, just so it was at an extreme, just to quickly get that going. Okay, so we're just going to put that away. Next is the visualizer. I based this highly off the videos that I saw, and just added in show ABB, show OBB, and show sphere because I didn't feel like typing those out every time I wanted them to be showcased. Let me pull up how the user would do that. So we'll just go to my demo files real fast and open up test geo. Okay, so test geo's got all these. So as seen here, all of the user has to do is visualizer, show sphere, and they put in the model center, the model radius for the sphere, and then the world and the color. I just have it set as random color. Okay, so that'll do for the visualizer. Next, let's get started with the collisions. What I had to do for the collidable is I had to add in all the new includes for all the volumes. I had to make a new function called set collider volume. So when the I'm just going to keep just here over. So when you set up the model for collision, you now have to call set model. So that sets the collision model for the collider volume to understand what it is, and then you have to set the collider volume, which is an enum that I have set up right over here. So yeah, click that. And then so for the collision volumes, they are all based off this collider volume base class, where it has the accept call for the visitor pattern, and then all the collision test cases, OBB, ABB, and my bounding sphere, just to showcase one of those classes, since a lot of them, they look fairly similar except for like math calls. So we got the right here, all the private variables for that, the setting up the collider, the min and max for the OBB, ABB, the accept call, and then last is the collision test. I have the base call just returning false if the user didn't set a collider volume, but this will probably just break the engine if they do not have a collider volume set on it and they have it registered to collide. So even though this is here, this will probably never get called. Since the engine will just crash if the collider volume isn't attached to an object due to an enum. But if somehow the user gets to this point, congrats to them. And then the last part of this before we open up the demo is the collision pair and single process. So single process, just changing the for loop, so it's just itself +1. And so that the collision pair processing had the prenup, so preening through the collision, making sure we go through group check, and then the outer sphere, which all my game objects have. So let's just go here. I don't know, that's the outer sphere test. Outer sphere definition, which all collidables have. It is the bounding sphere. So at the beginning, I create an outer sphere every time a collidable is made, so that way they have one. and I can use it for prenup. And then otherwise, this is just a group check call, and then definition, which is just in my math class as per I said earlier in the video. So without further ado, let's just see all these collisions in action. So as you can see here, I have, well, that's a little fast, let's slow that down. Okay, so we have all these types. So over here I have my ABB, as you can see, it's keeping track with the collision volume. And over here I have the OBB, as it's just following there, and in the center is my bounding sphere. So we're just going to have the bounding sphere hit all of these, and that'll showcase that all these are working. So first we're going to go over here to this group, and it's going to start calling bounding spheres in an OBB. So it's in an OBB area, I'd like to call it. And then we're going to come over here, and we're just going to place ourselves right, you know what, get that. I'm just going to go right here and rotate. And see, as you can see here, it is going off the collision based on the corner. So it's doing good on the accuracy check. And then I'll just go right over here and collision. Right. And that ends this part of the video demo. Part 2 is right next.